Okay, today we're going to look at section 2.4, linear equations in two variables and linear functions. So let's talk about linear equations in two variables. If we let A, B, and C represent real numbers such that A and B are not both 0, a linear equation in variables x and y is an equation that can be written in the form ax plus by equals c, and this is called standard form of an equation of the line. Note that our variables x and y are each first degree. They're to the first power. Okay, we've looked at graphing. Let's go ahead and graph one of these, see how this works. Graphing a line represented by an equation. Let's see. We have something like this. 4x plus 2y equals 2. To graph this, we need to get points. Now, while I'm sure you've heard that 2 points define a line, we want 3. So here's what we do. We just pick a point of x or y and see what y becomes. So I like to work with 0, which gives me 4 times 0 plus 2y equals 2. That means 2y equals 2 and y equals 1. So there's my first point, 0, 1. Okay, well, let's let y equal 0 and see what happens. That gives me 4x plus 2 times 0 equals 2. 4x equals 2, so x equals 1/2. And then let's just pick another random point. Well, let's go with, let x equal 1. What do I end up with? 4 times 1 plus 2y equals 2. So 4, subtract 4 from both sides, I get 2y equals -2, y equals -1. So now let's plot these points. 0, 1. 1/2, 0. And 1, -1. Now we have our points. Draw a line. And there we go. Okay, let's look at a couple of special cases. What if I have something like this? Y equals 1. Well, it doesn't matter what x is. Y is always going to be 1. So that is a horizontal line. What if we have something like this? -3x equals 12. Well, divide by -3x and we get x equals -4. Again, this case, vertical line. Going through the point -4, 0. That brings us to the next concept. The slope of a line passing through the distinct points x1, y1 and x2, y2 is essentially the change in y, or the rise over the change in x, which is the run. So this looks like this. Slope, we say it's m. So it's the change in y over the change in x. Don't worry, you don't need to know the delta symbols yet. So this is y2 minus y1 over x2 minus x1. Okay, first thing to keep in mind is it doesn't matter which point is x1, y1 and x2, y2. Just make sure that when you do your y2 minus y1, make sure the x2 is the x that goes with the y2. And there is one caveat here. Provided x2 minus x1 does not equal 0. So let's look at a couple examples. Or one anyways. So let's look at, what's the slope of a line passing through -4, 1, and 2, -2. Well, we simply take our y2, our slope equals y2 minus y1 over x2 minus x1. Doesn't matter which is which. We'll let this be 0.2. So y2 is -2 minus y1, which is 1, over x2, which is 2, minus -4, which is -2 minus -4. Oops, that's that right. 2 minus -4. So we have -3 over 6, which is -1/2. So what does this mean? This means for every 1 unit down, we go 2 units right. Okay? So let's think about this. What about the slope of a vertical line? Well, let's look at a vertical line. And we'll call it x equals 2. What's my y? Pick this point here. What do you have? X is 2, and we'll say y is 2. Doesn't really matter. Let's pick another point here. Here, x is 2, y is -2. So what's my slope? Well, my y2, 2 minus a -2 over 2 minus 2. And what happens? This is 0. So the slope for a vertical line does not exist. There is no slope. Okay? So what about the slope of a horizontal line? Let's look at this. Horizontal line. And we have, well, here's a point here. We'll call it 3, 2. And then here's a point here. And let's keep it simple. -3, 2. 2 points on the vertical line. y2, well, that's 2. y1, well, that's 2 as well. 2 minus 2. Over x2, well, we'll call this x2. -3 minus 3. 0 over -6 is 0. So the slope of a vertical line does not exist. The slope of a horizontal line is 0. Okay, so let's talk about, we did vertical, we did horizontal. Let's look at a line going in that way direction has a positive slope. For every unit up, we go a unit over. One going like this, for every unit up, we go a unit back. So that's a negative slope. So that brings us to our next formula to think about. It's called the slope-intercept form of a line. So, given a line with slope m and y-intercept 0b, the slope intercept form of the line is given by y equals mx plus b, and you've probably heard of this. So essentially, if I'm given the y-intercept of a line and the slope of the line, I can write the equation in slope-intercept form. Or if I'm given an equation, say 2x plus 4y equals 8, I can write it in slope-intercept form. I need to solve for y. So we'll subtract 2x from both sides. 4y equals negative 2x plus 8. Then I'll divide by 4 and I get y equals negative 1/2 x plus 2. Okay, so now what is my slope and y-intercept? Okay, well, my slope is right here. Negative 1/2. And my y-intercept, 0, 2. So now we can use this information and graph this equation. We have a point here. Y-intercept is 0, 2. So there's that point. Now, this is saying for every unit down I go to the right 2 units, right? Negative slope. Right there. Another one there. Or for every unit I go up, I go down or go left 2 units. Go to 3, I go here and there. So we're able to use the slope and the y-intercept to come up with multiple points and draw our line. Okay, now let's talk about linear and constant functions. So we'll let m and b represent real numbers where m does not equal 0. So a function defined by f of x equals mx plus b is a linear function. A graph of a linear function is a slanted line, which we've seen. Then a function defined by f of x equals b is a constant function the graph of a constant function is a horizontal line. So let's talk about some of this. So we have write an equation of the line that passes through the point -1, -1, -4, and has slope 3. Then write the equation using function notation. So what we're looking at here is I have a point and I have a slope. Unfortunately, I don't have my y-intercept, but remember the slope-intercept form, y equals mx plus b. Now I know an x and y that are on the line, and I know my slope, and I'm looking for b. So I could plug these values in, y equals -4, m equals 3, x equals -1, plus b. And I have -4 equals -3 plus b. Add 3 to both sides, and I get -1 equals b. So now I know b, and I know my slope. So y equals m, which is the slope, 3 times x, plus b, which is -1. Which means that in function form, y, we replace that with f of x equals 3x minus 1. And that's it. So looking at something like this. This would be x1 f of x1. And we'll call this x2 f of x2. Okay, that's our 2 points. Now, what I want to figure out is what is the average rate of change between these 2 points. Now I can draw a line like that that goes through those 2 points. The average rate of change would be the slope of that line. So my slope, my average rate of change, would be the slope, which would be f of x2 minus f of x1 over x2 minus x1. So let's look at something here. I'm looking at, okay, so we have f of x equals x cubed plus 2. And we want to know the average rate of change from x1, which is equal to -3, to x2, which is equal to 0. So in order to do this, we need to calculate f of x1, which is -3 squared plus, or cubed plus 2, which is what, -27 plus 2, or 25. So this point is -325. And then f of x2 is 0 cubed plus 2, or 2. So this point is 0, 2. To find the average rate of change, we simply take the slope between those 2 points. So my slope is equal to 25 minus 2 over -3 minus 0, which is 23 over -3, or -23 over 3. So that's how that works. Okay, now the book goes into using a graph to solve the equations and inequalities. So we can do this. We have a x plus 1 is equal to 2x minus 2. Then we have b x plus 1 is less than 2x minus 2. Then we have c x plus 1 is greater than or less than or equal to greater than or equal to 2x minus 2. Okay, so first we need to draw these lines. So we start with x plus 1. Okay, so looking at x plus 1, x is 0, so y equals x plus 1. Y is 1, x is 1, y is 2, x is -1, y is 0. Okay, so now let's look at y equals 2x minus 2. Okay, there we go. Now again, in this case, x is 0, y is -2, x is 1, I have 2 minus 2, which is 0, and what? We'll go 2. X is 2, I have 2 times 2 is 4 minus 2, which gives me 2. So now let's graph these. 0, 1, 1, 2, -1, 0. So this is y equals x plus 1. Okay. Let's look at y equals 2x minus 2. I have 0, -2, 1, 0, and 2, 2. These eventually intersect. And the point of intersection is 3, 4. So doing this graphically, where does x plus 1 equal 2x minus 2? Well, that's simply at x equals 3, right? Where they intersect. Okay, now where does x plus 1, make sure we label this, where does y equals x plus 1 less than, so where is this line less than this line? Well, that's starting here at 3 and here. So doesn't include 3 because they're equal there to infinity. And then lastly, where is x plus 1 greater than? Well, that's this whole stretch here. So we're starting at negative infinity and we're going to 3, and again, it's not included. So that's all well and good. But solving these graphically is not the best way to do this. So let's do this. The only one I'm going to look at for this is the equality. At this time, we're not going to look at the inequalities. Although really you should be able to see it because we're essentially going to graph these in our calculator. So you hit y equals. Okay, for y1, we want x, which is that button, x t theta n. Hit that button and then hit plus 1. Then hit your down arrow so that you're to y2. And then again, hit that same button, x t theta n. Oops. First hit 2 and then hit that button, x t theta n. Then hit -2. Okay, we've got both of them in there. So now hit graph. And I have a calculator issue. Okay, you should get your graph, which is going to look like our graph here. Then you can hit the button that says second on it. Then the button that says trace. And we want to calculate the intersection. which would be number 5. Once that's highlighted, the number 5 is hit enter, and it should go back to your graph and show you the intersection is 3, 4. So that's all we're going to cover on section 2.4 for today. That'll be it. Have a good day, and I will talk to you next time.